This week we're talking about MIDI a little bit more, which means you need to understand a little bit more about synthesis. Up to this point in the semester, you've primarily dealt with the manipulation or the processing, mixing, and use of real-world audio. You've gone out with your phone, which has a microphone, or you've used the microphone on your computer, or you've gone to sites such as freesounds.org or archive.org, found audio files or captured audio from the real world, brought it into your DAW, processed, mixed, played with, and created pieces that way. So the sound you've been using is all from the real world in some sort, likely. It's captured real world audio. Synthesized audio is the process of creating signals or audio signals specifically from nothing. In the case of the older analog world, this would be using electrical components to synthesize or generate some sort of signal. In the current computer digital world, this would be using computational means to create these signals. The tone generator plugin from Soka Labs that we've looked at the last couple weeks does this. It uses computational synthesis, creates some signals. Let's come over here to Reaper and we can look at it as a reminder. So we've got this tone generator can create a sine wave or a triangle wave, or a square wave, or just straight white noise. And of course, we can listen to any of those and hear it creating or generating those signals. There are generally two types of synthesis that we want to be thinking about. One is additive synthesis, and the other is subtractive synthesis. In additive synthesis, we add multiple signals together. So let me create a new thing here, and this is that program SuperCollider. Sorry if it feels a little overwhelming, but let's just presume we'll just create a sine oscillator, and we'll set a frequency of 100 and a mole of negative 24 decibels. Okay. And then I'm just going to duplicate that signal. But if we listen back to it here, great. And we're going to bring it up a little bit in frequency and not have it quite as soft. So you can hear that. Now in additive synthesis, we might add a number of these together. And let me also let me get the scope up. Oh, it's over there. I apologize. It was on the other screen. So let me now make this so we can see it. And we can bounce back and forth. Now, so maybe we'll add the next harmonic, which would be 300, and we'll make it just a touch softer. So now we have two sine waves together, and we can hear both of those sounds. And we could of course, keep going. We'll make this even a little bit quieter still. And so we start to create an additive synthesis example, essentially adding sounds together. And this makes sense, right? I have said that all sounds in our world can, in theory, be described as a series of sine waves at various amplitudes and phase relationships. So it would make sense that if we're trying to create some sort of sound, some sort of specific quality or timbre of a sound, that by adding up sine waves, for example, we could create those sounds. The problem is that could, in theory, then require us to have to add up thousands or tens of thousands or hundreds of thousands of sine waves together to get the one sound we want to create. In today's world with the computer, that might be possible. It's certainly more possible than it used to be. If you're thinking about an analog sound studio with electrical based synthesizers of some sorts, it was impractical at best, if not downright impossible, to have tens of thousands of oscillators. And back at the original start of electrical analog synthesizers, a synthesizer might have just a handful of oscillators. So it was not possible really to add together a large number of oscillators in order to create sound. So the other type of synthesis that became more common just out of pure practicality is subtractive synthesis. And in subtractive synthesis, essentially, we try to create interesting sounds by removing portions of the spectrum. So we might start with something like pink noise. And I'm going to make this quite soft, actually. You can hear that quality of pink noise. And let's actually just go back over to Reaper for a second as an example. And everything's on here. And I'm going to turn my noise up. And as you can see, I've got an EQ plugin here with a number of filters on it. And essentially, I am removing everything except for that, which is right around 1,000 hertz. So if we hear this and I turn it on, again, that's the same white noise original source. It's just that I am filtering it in such a way, subtracting out all of the frequency components I don't want, to be left with a single set of frequencies. In this case, I do create some sort of pitched type material. And it's the same basic concept. So subtractive synthesis could use any number of parameters or complex signals, removing portions of the spectrum to get to where we want to be. As an example, maybe we would use a square wave. So we could put a couple things together like a square wave here. And then... Sorry about that. So we can start to make complex sets of sounds. Again, this is a square wave and noise put together, still filtered, subtracting out the portions we don't want, thereby resulting in something that we could use. So that's the basic idea of subtractive synthesis. And I just want you to kind of have a basic idea of how this works for the time being, because as we move into MIDI, this will be the predominant way that we create sounds through subtractive synthesis.